Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 3, Structural Analysis, Questions and Answer. 1. State Muller Breslau Principle. Muller Breslau principle states that, if we want to sketch the influence line for any force quantity, like thrust, shear, and reaction, support moment or bending moment, in a structure, we remove from the structure the restraint to that force quantity and we apply on the remaining structure a unit displacement corresponding to that force quantity. The resulting displacements in the structure are the influence line ordinates sought. 2. Write the uses of Muller Breslau principle. It is the most important tool in obtaining influence lines for statically determinate as well as statically indeterminate structures. It is used as the straight application of Maxwell's reciprocal theorem. 3. Define the term equivalent uniformly distributed load. A given system of loading crossing a girder or structure can always be replaced by a uniformly distributed load longer than the span, such that the bending moment or shear force due to the static load everywhere is at least equal to the caused by the actual system of moving loads. Such a static load is known as equivalent uniformly distributed load. 4. What is meant by maximum shear force diagram in influence line? Due to a given system of rolling loads, the maximum shear force for every section of the girder can be worked out by placing the loads in appropriate positions. When these are plotted for all the sections of the girder, the diagram that we obtain is the maximum shear force diagram. This diagram yields the design shear for each cross-section. 5. What do you understand by the term reversal of stresses? In certain long trusses the web members can develop either tension or compression depending upon the position of live loads. This tendency to change the nature of stresses is called reversal of stresses. 6. State Maxwell-Betti's theorem. In a linearly elastic structure in static equilibrium acted upon by either of two systems of external forces, the virtual work done by the first system of forces in undergoing the displacements caused by the second system of forces is equal to the virtual work done by the second system of forces in undergoing the displacements caused by the first system of forces. Maxwell-Betti's theorem helps us to draw influence lines for structures. 7. Draw the influence line for radial shear at a section of a 3-hinged arch. H equals cos dash sin, where is the inclination of tangent at x. 8. What is the necessity of model analysis? When the mathematical analysis of problem is virtually impossible. Mathematical analysis, though possible, is so complicated and time-consuming that the model analysis offers a shortcut. The importance of the problem is such that verification of mathematical analysis by an actual test is essential. 9. Sketch the ILD for the normal thrust at a section X of a symmetric 3-hinged parabolic arch. H equals sin plus cos, where is the inclination of tangent at X. Define Maxwell's reciprocal theorem or Betti's theorem. The work done by the first system of loads due to displacements caused by a second system of loads equals to the work done by the second system of loads due to displacements caused by the first system of loads. Define similitude. Similitude means similarity between two objects, namely the model and the prototype, with regard to their physical characteristics. Geometric similitude is similarity of form. Kinematic similitude is similarity of motion. Dynamic and/or mechanical similitude is similarity of masses and/or forces. State the principle on which indirect model analysis is based. The indirect model analysis is based on the Muller Breslau principle. Muller Breslau principle has led to a simple method of using models of structures to get the influence lines for force quantities like bending moments, support moments, reactions, internal shears, thrusts, etc. To get the influence line for any force quantity, remove the restraint due to the force. Apply a displacement in the direction of the force. Plot the resulting displacement diagram. This diagram is the influence line for the force. What is the principle of dimensional similarity? Dimensional similarity means geometric similarity of form. This means that all homologous dimensions of prototype and model must be in some constant ratio. What is Begg's defermeter? Begg's defermeter is a device to carry out indirect model analysis on structures. It has the facility to apply displacement corresponding to moment, shear, or thrust at any desired points in the model. In addition, it provides facility to measure accurately the consequent displacements all over the model. Name any four model-making materials. Perspex, plexiglass, acrylic, plywood, sheet araldite, and bakelite are some of the model-making materials. Microconcrete, mortar, and plaster of Paris can also be used for models. What is dummy length in models tested with Begg's defermeter? Dummy length is the additional length, of about 10 to 12 mm, left at the extremities of the model to enable any desired connection to be made with the gauges. What are the three types of connections possible with the model used with Begg's defermeter? Hinged connection, fixed connection, floating connection. 18. What are the uses of a micrometer microscope in model analysis with Begg's defermeter? Micrometer microscope is an instrument used to measure the displacement of any point in the z directions of a model during tests with Begg's defermeter. What is meant by yield stress? Most structural materials have under gradually increasing strain an elastic and plastic stage. Plastic stage mark the stage at which increased strain does not produce in stress. The stress consequent to stretching stabilize at a value is known as yield stress. What are the basic conditions to be satisfied for elastic analysis? Continuity equation. Equilibrium condition. Limiting stress condition. What are the basic conditions to be satisfied for plastic analysis? Mechanism condition. The ultimate load or collapse load is reached when a mechanism is formed. There must, however, be just enough plastic hinges that a mechanism is formed. Equilibrium condition. The summation of the forces and moments acting on a structure must be equal to zero. Plastic moment condition. The bending moment anywhere must not exceed the fully plastic moment. List out the shape factors for the rectangular, triangular, circular and diamond section. Rectangular section, S equals 1.5. Triangular section, S equals 2.346. Circular section, S equals 1.697. Diamond section, S equals 2. What are symmetric frames and how they analyzed? Symmetric frames are frames having the same support conditions, lengths, and loading conditions on the columns and beams of the frame. Symmetric frames can be analyzed by beam mechanism, column mechanism. What are unsymmetrical frames and how they analyzed? Unsymmetric frames have different support conditions, lengths, and loading conditions on its columns and beams. These frames can be analyzed by beam mechanism, column mechanism, panel or sway mechanism, combined mechanism. What is the effect of axial force on plastic moment when a section is subjected to axial force? Thus far the cross-sections considered are only carrying moment. In the presence of axial force, clearly some material must be given over to carry the axial force and so is not available to carry moment, reducing the capacity of the section. Further, it should be apparent that the moment capacity of the section therefore depends on the amount of axial load being carried. Considering a compression load as positive, more of the section will be in compression and so the neutral axis will drop. What is a mechanism? What are the different types of mechanism? When an n-degree indeterminate structure develops n plastic hinges, it becomes determinate and the formation of an additional hinge will reduce the structure to a mechanism. Once a structure becomes a mechanism, it will collapse. Types of mechanism: beam mechanism, column mechanism, panel or sway mechanism, gable mechanism, combined or composite mechanism. What are the methods of plastic analysis? Static method, lower bound theorem. Kinematic method, upper bound theorem. State the lower bound theorem or static theorem of plastic collapse and upper bound theorem of plasticity. Lower bound theory states that the collapse load is determined by assuming suitable moment distribution diagram. The moment distribution diagram is drawn in such a way that the conditions of equilibrium are satisfied. Upper bound theory states that of all the assumed mechanisms, the exact collapse mechanism is that which requires a minimum load. Define shape factor. The shape factor, S, is defined as the ration of the plastic moment of a section to the yielded moment of the section. The shape factor is also the ratio of plastic modulus of the section to the elastic modulus of the section. Equals. Define the term load factor. Plastic analysis can tell us at what load, or load combination, a structure will collapse. This will help us design structures for a desired safety factor on limiting loads. This safety factor is usually termed as load factor. It is also defined as the ratio of collapse load to the working load. Equals. Define collapse load. The load that causes the n+1, the hinge to form a mechanism is called collapse load, where n is the degree of statically indeterminacy. Once the structure becomes a mechanism, it will collapse. What are the limitations of load factor? The analysis procedure does not give us any clue if at a load divided by the structure behaves well, meaning whether the stresses are within limit. So we have to check the stresses at crucial points by conventional elastic method. The assumption of monotonic increase in loading is a simplistic, native assumption. But it is convenient, and so we stick to it. Explain the term plastic hinge. When a section attains full plastic moment m, p, it acts as hinge, which is called a plastic hinge. It is defined as the yielded zone due to bending at which large rotations can occur with a constant value of plastic moment m. P. What is plastic moment? When the moment is further increased, there will be a stage at which all fibers from top to bottom of the section will completely yield and the section would not be able to take any further moment. The resisting moment corresponding to this fully plastic stage is called the plastic moment m. P. Define plastic modulus of a section. The plastic modulus of a section is the first moment of the area above and below the equal area axis. It is the resisting modulus of a fully plasticized section. Equals /2 1 plus 2. Define moment redistribution. Moment redistribution refers to the behavior of statically indeterminate structures that are not completely elastic, but have some reserved plastic capacity. How is the shape factor for a hollow circular section related to the shape factor of an ordinary circular section? The shape factor of the hollow circular section equals a factor k * shape factor of ordinary circular section. H equals H times 1 3 / 1 4. Give the governing equation for bending. The governing equation for bending is given by / equals / where m equals bending moment, I equals moment of inertia, S equals stress, y equals center of gravity, distance 39. What is meant by plastic analysis of structure? The analysis of beams and structures made of such flexural members are called plastic analysis of structure. What is the difference between plastic hinge and mechanical hinge? Plastic hinges modify the behavior of structures in the same way as mechanical hinges. The only difference is that plastic hinges permit rotation with a constant resisting moment equal to the plastic moment MP. At mechanical hinges, the resisting moment is equal to 0. List out the assumptions made for plastic analysis. Plane transverse sections remain plane and normal to the longitudinal axis before and after bending. Effect of shear is neglected. The material is homogeneous and isotropic both in the elastic and plastic state. Modulus of elasticity has the same value both in tension and compression. There is no resultant axial force in the beam. The cross-section of the beam is symmetrical about an axis through its centroid and parallel to the plane of bending. State the principle of superposition of forces. When a body is subjected to a number of external forces, the forces are split up, and their effects are considered on individual sections. The resulting deformation of the body is equal to the algebraic sum of the deformations of the individual sections. Such a principle of finding the resultant deformation is called the principle of superposition. Define statically determinate structure. If the conditions of equilibrium, i.e., SH equals 0, SV equals 0 and SM equals 0 alone are sufficient to find either external reactions or internal forces in a structure, the structure is called a statically determinate structure. Define statically indeterminate structure. If the conditions of equilibrium, i.e., SH equals 0, SV equals 0 and SM equals 0 alone are not sufficient to find either external reactions or internal forces in a structure, the structure is called a statically indeterminate structure. Define compatibility in force method of analysis. Compatibility is defined as the continuity condition on the displacements of the structure after external loads are applied to the structure. Differentiate the statically determinate structures and statically indeterminate structures. No. Statically determinate structures. Statically indeterminate structures. 1. Conditions of equilibrium are sufficient to analyze the structure. Conditions of equilibrium are insufficient to analyze the structure. 2. Bending moment and shear force is independent of material and cross-sectional area. Bending moment and shear force is dependent of material and independent of cross-sectional area. 3. No stresses are caused due to temperature change and lack of fit. Stresses are caused due to temperature change and lack of fit. 4. Extra conditions like compatibility of displacements are not required to analyze the structure. Extra conditions like compatibility of displacements are required to analyze the structure along with the equilibrium equations. Define force transformation matrix. The connectivity matrix which relates the internal forces and the external forces is known as the force transformation matrix. Writing it in a matrix form. Q equals BR, where Q equals member force matrix vector, B equals force transformation matrix, R equals external force load matrix vector. What is transformation matrix? If and bear the matrices of two linear transformations, then the effect of applying first on then BTO a vector's is given by, this is called the associative property. In other words, the matrix of the combined transformation A followed by B is simply the product of the individual matrices. Describe the uses of force method. What are the basic steps in the force method to find internal forces in statically indeterminate structure? With the advent of computers, matrix methods of solving structures have become very popular. The behavior of a structure can largely be defined by defining the force-displacement relationship in the form of a matrix. Steps. Applying a force on the structure. Working out the internal forces and moments. Computing displacement and rotations at specific locations, making use of the values in the above step. What are the basic unknowns in stiffness matrix method and aim of the stiffness method? In the stiffness matrix method, nodal displacements are treated as the basic unknowns for the solution of indeterminate structures. The aim of the stiffness method is to evaluate the values of generalized coordinates R. Knowing the structure stiffness matrix K and nodal loads R through the structure equilibrium equation. R equals KR. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.